Right, today we're going to do two simple topics. We're going to do distance time, velocity time graphs, which are kind of the same thing, and we're going to look at stopping distance, because this is the one that people forget the key bits about it. So let's do it nice and quickly. Distance time graphs. We need to be able to represent, we need to understand the different shapes of the graph. We need to know what they mean, and we need to be able to link them in terms of this key vocabulary. Now, if you can do this already, pause it, see if you can do it. If not, you need to have two key things in your head. It's this. What is the gradient and what is the area underneath this graph? Well, the gradient of a distance time graph is the speed, and the area underneath it is nothing. It doesn't mean anything for this one. So remember, for a distance time, gradient is speed, and we don't care about the area underneath it. Now this should be easy. Gradient is constant and negative, so that means it's going at constant speed towards the origin. My distance is decreasing. Constant gradient, so it's a constant speed away from the origin this time. Constant gradient, look, my distance isn't changing. It's the same all the way along. So that means I'm stationary. What's happening here? Well, I've got a positive gradient and it stops, and then a negative gradient. So that must be a change in direction. What's happening to my gradient on this one? It's going up, so I must be accelerating. My gradient's going down, so I must be decelerating. Obviously, it could be a combination of these, one after the other, and you could look at the different sections. The key is the gradient is the speed. Well, let's look at Usain Bolt's 100-meter record. Let's see if we can describe this. Can you see there's an upward curve here? So he's accelerating, and a constant gradient, so it's a constant speed away from the origin. Obviously, he's running along the track. Alright. Velocity time graphs. Now people get these confused all the time with distance time graphs. So keep it in your head. Velocity time. Double check. Now which one of these is which? Again, let's go back to our key learning points. For the distance time graph, we had that the gradient was the speed and we didn't care about the area underneath. How about a velocity time graph? Well, the gradient of this one is now the acceleration and the area underneath is the displacement. Don't get these confused. Pause it, write that down, make a flashcard. That's what you need to get in your head. And again, people might get this confused with the distance time graph, but we're not going to. We're going to know that gradient is the acceleration, constant gradient is a constant acceleration. Decreasing gradient, well, I'm still accelerating, the velocity is still going up, but it's at a lower and lower rate. This one is an acceleration, my velocity is still going up, but it's at an increasing rate, so I'm accelerating faster and faster, the gradient's going up. And what about this one? Well, this one's the one I put ... It's going to be a constant speed. Now, if you got that in your head, if you didn't think about it, you might think this is stationary, and you might get it confused with the distance time graph, but you're not going to. You know the gradient, you know the speed's the constant, so I'm always moving at constant speed. Let's look at this. Because I told you the area underneath it is the displacement. I've got two areas now. I've got A and B. Now the final displacement for this one is all of that minus this. Why? Because it's in the negative region of the velocity bit. This is all positive velocity. I'm going away from the origin here. I'm coming back towards it here, so I've got to subtract it. If I didn't have this bit, that would be my displacement. Be careful about the negative signs. Let's move on to stopping distance. It's the distance it takes to stop. Now, all of the time I hear people saying the stopping distance is the time it takes. Nonsense. It's measured in meters, not seconds. So the thinking distance will be the distance you travel. What are you doing in that time? You're reacting. So I'm driving along, animal comes into the road, okay? I don't immediately put on the brakes, do I? Because my brain doesn't work like that. I travel from here maybe to here while I'm reacting. That is my thinking distance. I then put the brakes on, and the braking distance is the distance I travel when I have the brakes on. So from the moment I put the brakes on, I don't immediately stop, I carry on until I stop. So I have my thinking distance while I was reacting, then my braking distance, and the whole thing is my stopping distance. So you've got the equation, stopping distance equals thinking distance plus braking distance. The distance, so the unit's going to be meters. Of course, you could have kilometers, but we're most likely talking about meters here. We now need to look at the factors that affect these different things, and we need to be able to split them up into thinking and braking. Why don't you give it a pause? Why don't you try and list them? If not, here we go. Thinking distance. I've got fatigue, I've got all the things that affect my reaction time. Okay? And the most important one is how fast you're going. Because if you're going really fast, obviously you travel further while you're reacting. And braking distance, what have we got? Well, the quality of the brakes, the quality of the tyres, so look at the tread on the tyres, the road surface, if it's loads of potholes and stuff, it'll take you longer to brake, a longer distance to brake. The mass of your car, if you've got loaded up with shopping, your braking distance increases for the same speed. Weather is very important, and again, how fast you're going. You need to make sure you split them up into two things. You need to remember this equation. Alright, so that's it. Distance time graphs, velocity time graphs, stopping distances. Go away, go and learn it. Good luck.